Hello and welcome to another CS200 mini lecture. Today we'll talk about generics, and this covers chapter 15, sections 15.1 through 15.3. I'll also be supplementing it with additional examples that help convey some of the topics in more detail. So let's get started. First, we need to understand the topic of a comparable interface. So a comparable interface is when we want to sort values. Here we have an array list. Remember, an array list is a reference type, meaning it's an object. It can be an array list of different data types, and we may want to sort them. We want to make sure that they're called comparable data types. In other words, values that if we do a sort, which is a very common type of operation, what we do with lists, we might want to sort them in numeric or alphabetical order. And they need to be comparable. So we need to compare like kind items. So numbers with numbers, letters with letters, strings with strings, doubles with doubles, for example. There is a collections class that Java provides that provides these methods that operate on different types of lists, such as an array list. And remember, an array list can be a composite of different types of data. Well, they have to be objects. But let's take a look at an example from 15.1.1. So this is the code that is brought in from the Zybook. Here we have a bunch of imports. Notice one in particular. This one is Java util collections, which we'll see why it's useful here in a minute. What we do is we want to sort our array list, and we initially declare a scanner object. And then we have a final, which means it's a non-changeable or static value. And then this is going to be the number of elements, which is 5. So that's the number of elements we're going to read in. Then we declare an array list of integer type, which is going to be of size 5. And then we prompt the user for 5 different elements. So we loop through with our counter from 1, as long as it's less than or equal to 5. We're going to read in the value, and then here's where that collections comes in handy. So what we're going to do is we're going to sort it, but instead of having to write a different method for sorting integers, for sorting character values, for sorting doubles, we can actually do it with a single sort method. Now this is built into the collections class, which is nice. So what it's going to do is the 5 numbers that we enter, it's going to sort them automatically, and then we're going to print them out. Let's go ahead and run this. First we'll compile it, and now we'll run it. It's prompted me for numbers. I'll just put in some numbers. And you can see it puts them in sorted order. Now this is kind of nice to have some method that, despite any type of inputs, is going to sort them according to how we would want them to be sorted. So these are comparable types. You can see here we have 5 integers, and this would work similarly. We could write a similar method to get characters and sort them as well. So what's nice is to have a compare to. So if we have a bunch of employee records, we might want to write something to allow them to compare different values. So we see here in this idea, we have public class employee data, and you can see it's built up of a bunch of different elements, 2 strings, 2 integers, and we can assign it. We override the compare to method, and this one we allow it to compare based on department number first. So we set a comparison value, which tells it what we want to compare. Now, if they're in the same department, we want to use name. So this gives us a second item to sort on. And then this can return the comparison value. So in the employee records, we would enter the values and loop through. And this would get the values and put them in sorted order. I'm not going to run this in BlueJ, but I think you can see here there's many examples and we can put them in order. So what it does is you can see that it puts it in department order first and then alphabetical order. So this is nice. This allows us to sort on multiple different key values, which is getting more into like database theory. However, what can do a lot with Java that we didn't think we'd have to do with writing a lot of code. This one allows us to do it quite easily. So remember, the implements keyword tells the compiler that the class implements instead of extends an interface. Remember we talked about how to implement as opposed to a derived class? This is one example. When we want to sort using employee IDs, notice here we implement the comparable class on employee data. So this will allow us to do an ascending order sort when we go through and override the standard. Because normally it would just sort on the first value, but we may not want to sort on the first value. This allows us to sort on a different key as opposed to just what is first in the record. Okay, I'm going to skip this challenge activity and go on to the next chapter. I think generic methods is important to know. So what I'd like to do now is talk about generic methods. So one of the nice things about generic methods is we can implement a method that has an identical behavior, only differing in the data type that it's built on. This is nice because we can use these with parameterized types. The idea behind this is to allow types such as integer with a capital I, string with a capital S, because remember they're reference types, not primitive data types, to be parameters to methods, classes, and interfaces. And with this, it's possible to create classes that work with different data types. So we can define one type of method and use that kind of method to have behavior that works the same whether we have an integer, for example, a double, or a character. And of course, these would be references. We can't use them with primitives. The nice thing about this is it's more elegant. Again, you could get around this by just writing a single method for integers, a single method for characters, and a single method for doubles. So is this a necessity? Not really, but it is a nice thing, a nice way around things. There's something in C++ called a template, and a generic method is very similar to this. So what we do is to declare a method, we would declare it as follows. Okay. So here we want to find the minimum of 3 integers. We declare it's going to pass back an integer, notice the capital I, triple min integer. So we're going to find the minimum of 3 integers. And of course we pass as we have as a parameters 3 different integers. And then we're going to pass back the minimum value, which is an integer. Again, they're objects, reference types. That's why they have the capital I. So we declare integer min value. Min val equals item 1. So we start off by saying that it's equal to the first one we get. And then if we do a comparison, and remember we have to do the compare to, we have to use a method just because these are reference types, they're not primitive types. So we do this compare to, and we get a value less than 0. So what does that mean? That means that min val is going to be equal to item 2. So if it's less than 0, that means item 2 is the smaller value. We do the same thing with item 3, and then we're going to return min val. Very simple method. But now if we do characters, you can see that the layout of these two methods is almost identical. The only difference is we're using characters instead of integers. So it's redundant in a way. Another thing is, as we'll see later, we can have the compiler tell us when we've got an error as opposed to waiting till runtime, which is really nice if you're a developer. It lets you save face for sure. So a generic method is one that has a special type parameter that can be used in place of types in the method. So what we mean by this is what we see here in yellow. And notice we're extending. So we have, notice the angle brackets, public static, the type extends comparable, and then we have another angle bracket and then two close angle brackets. So this is kind of, it's a different way of stating the fact that we don't know what the type is, but we're going to make it generic enough so that whatever we pass in, this method can handle it. So this is also calculating the minimum. So we have min val equals item 1. And notice instead of having integer here, we have the type. So this is just a comparable class or comparable item. And we don't know if it's going to be an integer or a string at this point. The only thing we know is we're going to get 3 values, and then we're going to take the same process that we followed before. So here you can see if we have 3 values as numbers, we're going to pass it the same as if we have 3 letters or 3 strings. So this is kind of nice. It's elegant. And you can see that the output is exactly what we would expect using this same method. We don't have to write 3 methods. We can write 1. So it reduces the possibility of having an error, because when you write 3 methods, typically there's more chance of getting one wrong than just writing a single one. So we say these are type bound. So this binds the type to a specific class. So this says, okay, I don't know if I'm going to get a character, a string, a double, an integer, but when I do, I will tell you what it is. So by doing this, we're allowing the compiler at runtime to know what it's getting. So not at compile time. So here's some other examples. And then let's look, this is method generics. Let's talk about class generics now. So classes can be nearly identical. We talked about methods being nearly identical, but classes can do the same. So notice the syntax for this. Here we have a class called triple int. We have 3 different integers, and then we're going to print them out. Here we have 3 shorts. We're going to do the same thing. So a generic class allows us to have a special type parameter that we can use in place of the type, the data type in the class. And look at the syntax. It's very similar to what we saw with the methods in last subchapter. We notice that it has the angle bracket, the type, and again, the type doesn't have to be that specific word. It just has, it's not a keyword. It's just a value that we give to a generic type. Much like we did with scanner objects, we called them SCNR. We don't have to call them that. It's just by default that makes it easier. So extends is necessary because what we're doing is we're extending comparable the type. Okay, so that has to match. So we have 3 private values here, and we don't know right what they are at the moment. They could be short, they could be ints, they could be characters. So we read these values in. So we declare triple item, and then we're going to print the values. And then we can also print the minimum data member value, much like what we saw with the previous iteration. So here we do by passing 3 integers and then passing 3 shorts, and we can get the function to work much like we would expect. So how do we do it with multiple parameters? They can be bound to different types, as you can see here. We have type 1 extends bound type 1. and type 2, etc. So we can do something to count the number of times the same word is read from the same user input. And I'm going to skip over this and go to some other examples because I think other examples will help us understand. Let's go to Blue Jay. So let's take a look at this example. So we can use an array of different types using the single generic method. So here we have an array of integers, an array of doubles, an array of characters, and we're going to print these values out. And notice here we have a method, and look how we declare it. So it's print array, and we have elements. These could be integers, these could be doubles, these could be characters, and they're going to be an input array. So again, we're making this as generic as possible because we don't know what we're going to be passing in until runtime. So then we want to, all this is doing is just displaying the elements. And then here's our main or our driver. And in this case, we're going to pass an integer array, a double array, or a character array. And you can see the values here are representative of the type that we'll be passing in. So let's compile and run this. So here are the values that we get, and they just print out like we would expect. But notice we've done this print using this very generic method. Despite having different types of data, we're able to print these out using this one method. Let's talk about bounded type parameters here for a minute. There might be some times when you'll need to restrict the kinds of types that are allowed to be passed to a type parameter. So for example, we might only want to pass in numbers, not characters, to instances of number or its subclasses. And we would use a bounded type parameter in this situation. So to declare a bounded type parameter, we list the type parameter's name followed by the extends keyword followed by its upper bound. So here we have t, that's our type parameter, extends, and then we have the parameter's name followed by the extends keyword, and then followed by the upper bound. Okay, we know we're going to get 3 values. So what this is doing is the maximum, and then it's, despite what we're passing in, it's going to say the maximum. Okay, so we have 3, 4, and 5. That's what we're going to print out. So we're matching the %d to each element in order. And then we're going to call this maximum 3, 4, and 5 to fill in this value. And likewise, when we have these doubles, we're going to do that. And then last, with these strings, we're also going to do the same thing. So let's compile this and run it. And we see here the maximum of 3, 4, and 5 is 5, just like we would expect. We get the values. And notice it handles both doubles, integers, as well as strings, just as we would want. Notice it takes the p as the highest value and alphabetizes it. So now let's take a look at an example of a generic class. Here we have box, which takes type. Now we don't specify what the type is, so at compile time, the Java compiler is not going to know what it is. We declare a private variable of type capital T, which will give the name lowercase t. And you can see we add the value by assigning it as a parameter and then passing an argument to that particular add method. And then we also have a get. So in our main here, we declare a box of type integer. Notice the angle brackets match what the class definition is up top. So this looks like a non-generic class declaration, except we have a type parameter section up top. And as with generic methods, which we just saw, The type parameter section of a generic class can have one or more type parameters separated by commas. In this case, we just have one. These, like the capital T here, are called parameterized classes or parameterized types because they accept one or more parameters. So when we run this, it gives us a value regardless of whether we use the integer or the string as the class declaration. So this gives us a lot of flexibility. So here's another example of a generic method. Here we have a static and then T being the type, void, generic display. And then we pass it this parameter, type T, which is an element. Okay, so what we're going to do is we're just going to print out the value. And here we have our driver. We will pass it generic display, which will take the number 123, and it will print it out and tell us what class we're using, and then also print out the element we pass it. We'll do the same thing, passing it to the same method using a string and then using a float. So let's compile it and run it and see what we get. So we can see here that we're using this class and this name, and this is the element value. So again, we can pass it with different data types, and we can also just use that simple method to get the values we want. Now there's times in which we can't use compatible types. So let's take a look at this example. So here, I've already tried to compile it, but what we're doing here is we're trying to set this string object to an integer object. And it doesn't allow it because they're incompatible types. The nice thing is we know this at the time of compilation. So there's no chance of us running into a problem when the program is live. So again, we have our constructor, and then we return that value. So this is just an example showing that we get an error when we write this, and then we would know that we need to handle this a little bit differently. And one way we can handle it is with those generic types. Let's look at another example of bad casting. In this one, we're trying to cast the value, but the compiler is going to allow this, right? So what we have is we have an array list, and we're going to add Java, we're going to add Python, and we're going to add the number. So it's a different type, but we're going to get a runtime instead of a compile time exception. We add that 42. So let's compile it, see it works fine. And now when we run it, we're going to see that it gave us an error. And let's see what the error says. We get class Java lang integer cannot be cast to Java lang string. So in the first example, we caught it at compile time. This one, we got it at runtime. So the compiler didn't catch this conversion, so this casting example. Here's another one that's also not working. So we have Java and Python, and now we're going to try to add 42. And the reason is when we compile it, it says we can't convert it. So in this case, it's catching it at compile time as opposed to runtime. So let's see another example of how we can do this. Here we have something similar where we don't need to do typecasting because we have an array list of string. We have Java and Python, and then we can just print out the values. Okay. And again, this just loops through and prints them out. So we close this, run it. So there's a couple things that generics have over non-generic code. Sure, they're more complex. However, we can reuse this code more often. We can write a method or a class or an interface once and use it for any type we want. Also, generics make errors appear at compile time, which is what we want as programmers, rather than runtime. So it's easier to get and resolve the issues when it's not in your customer's face. So if you want to create an array list and store the name of students, and if by mistake the programmer adds an integer object, you can see those previous two examples, we would catch it. One example was where it would be caught at compile time. The other one would not, and it'd be caught at runtime. So we want to make sure that at the type, when we define the array list, we specify that the list only takes string objects. So here, we only take string objects, and we can specify that early on. Another benefit of generics is individual typecasting is not needed. So if we don't use generics, so the example that we saw, every time we retrieve data from an array list, we would have to typecast it. And that is a big headache. So if we already know our list only takes string data, we don't have to typecast it every time, just like we saw in that last example. It promotes code reusability, which in software engineering is a big plus. And also in implementing generic algorithms, we can implement these algorithms that work on different types of objects, and they perform similarly, and they're safe as well. So my suggestion is, yes, you can get around these by using or writing different methods and classes. However, this is an elegant way, and it's helpful as you enter your programming career to know about how generics work, their values, and their use, as well as how to write